the relationship between the natural log function and 1 over something. We know that ln of 4 minus x is the integral of minus 1 over 4 minus x dx. And now we look at this and we say, well, this looks like something we can find the power series of. So in order to get to the power series of ln of 4 minus x, we're going to look for the power series of minus 1 over 4 minus x and then integrate it term by term. So how do we do that? Well, remember that we know that 1 over 1 minus star can be represented as the sum from n equals 0 to infinity of star to the n. So how can we make minus 1 over 4 minus x look like 1 over 1 minus star? So the first thing we can do, if we start off with minus 1 over 4 minus x, is just put this minus 1 out front, so we have minus 1 over 4 minus x. Now that's closer, but how can we make it look like 1 over 1 minus star? Well, if we factor out a 4, that'll make this a 1 here. So let's do that. Let's write it as minus 1 over 4 times 1 minus x over 4. And now this is minus 1/4 times 1 over 1 minus x over 4. Just pulling this 4 here out front. Now we have 1 over 1 minus star. So this right here is our star. So now this is minus 1/4, and 1 over 1 minus star is the same as the sum from n equals 0 to infinity of star, in this case x over 4, to the n. And now, since we're going to want to be integrating this, let's go ahead and put this 4 back in to the sum. So this would be the sum from n equals 0 to infinity, and we'll also pull the minus 1 in, minus 1 times x to the n, and now I've got 4 to the n in the denominator here, times another 4 in the denominator, so it's over 4 to the n plus 1. So let's just write out a few terms of this series right here so that we can see what happens when we need to integrate it. So when n equals 0, then we just have minus 1 over 4. That's for n equals 0. What about when n equals 1? When n equals 1, we have minus 1 over 4 squared x. When n equals 2, we're going to have minus 1 over 4 cubed x squared. So this right here, this infinite series, is what we can replace the minus 1 over 4 minus x with. And we need to integrate it. So now we have that ln of 4 minus x equals the integral of this power series here. And let's just write out some of the terms here. Minus 1/4 minus 1 over 4 squared times x minus 1 over 4 cubed times x squared, etc. So that's what we have to integrate. So how do we integrate this? Well, minus 1/4 would integrate to minus 1/4 x. Minus 1 over 4 squared x would integrate to minus 1 over 4 squared, and then the x would be integrated x squared over 2. So it'd be minus 1 over 32 x squared. Then what about this term? Well, this term we'd have 1 over 4 cubed, and the x squared integrates as 1/3, or x cubed over 3, etc. And we have a plus c here because we have an indefinite integral. So now all we need to do is figure out what c is. All of this equals ln of 4 minus x. Since we're doing the series around x equals 0, these two things have to be equal for x equals 0. So when x equals 0, this side of the equation is just ln of 4, and this side, every term is going to fall out except for c. So that tells us that c is ln of 4. So in other words, we now know that ln of 4 minus x equals minus 1/4 x minus 1 over 4 squared times 2 x squared minus 1 over 4 cubed times 3 x cubed, etc., plus ln of 4. And ln of 4 is the constant term, so technically we would write this as ln of 4 minus 1/4 x minus 1 over 4 squared times 2x squared minus 1 over 4 cubed times 3x cubed, etc. So now if we want the coefficients, these are the coefficients. How can you check? Well, if you graph ln of 4 minus x and you graph the first several terms that you think are correct, then those graphs should be very, very close to one another around x equals 0. So that's what I've done here. So here you'll see that I graphed ln of 4 minus x in red, and then I graphed the first 4 terms of the series in blue. And you'll see that around x equals 0, they're very, very close to one another. That's how you do these.